Hey, this is Math 6, Unit 6, Lesson 15, Equivalent Exponential Expressions. Alright, so we begin first of all with a little activity called up or down. It says find the values of 3 to the x power and 1/3 to the x power for different values of x. And then take a look at what patterns do you notice. So what we're going to want to do here is we're going to want to take the value given here in the x column and substitute that in the place for the x in each one of these little expressions. So the first one becomes 3 to the first power, which is simply 3. When we do the next one, 3 to the second power, that's 3 squared, and 3 times 3 is 9. When we do the next one, we get 3 to the third power, and then we could think of it this way. I could do 3 times 3 times 3 again, but really it's 9 times 1 more 3. 9 times 3 is 27. And then 3 to the fourth power is 27 times 3, which is 81. So our solutions for this column give me a 3, a 9, a 27, and an 81 when we just substitute this value for x right there for that exponent. Now let's see what happens when we do the one with the fraction. Okay, so this becomes 1/3 to the first power, which is simply 1/3. The next one is 1/3 times 1/3, or 1/3 squared, because our next one is squared, and that becomes 1, and then I'm going across this way, it's 9, 1/9. The next is a 1/3 times a 1/3 times a 1/3. So again, 1 on the top, 3 times 3 is 9, times 3 again is 27. And you might be seeing a pattern here because the last one is going to be a third times a third times a third times a third, because it's 1/3 of the fourth power. So you have 1 there, and this is 27 times 3, which is still 81. So what patterns do you notice? Well, a couple of patterns I notice is that in this column here, as I look down this column, the numbers seem to increase as the exponent increases. So in the column of the 3x, as the exponent increases, the value increases. And again, I'm just writing some shorthand notes here. When I look at this one here, with the 1/3 of the x power, what happens as the exponent increases? As the exponent increases, the value here actually becomes smaller. So the value decreases because it's a fraction. Okay? So 1/3 of a pie is a whole lot more than 1 out of 81 pieces, right? That's like taking your pie and breaking it up into 3 pieces. That's a bigger chunk than if I took the pie and chopped it up into 81 pieces, which would be a lot of tiny, 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 tiny pieces. Not even there yet, but you get the idea. Itty bitty compared to a big chunk. Okay, the other thing I notice is that in the two columns, the numbers are what? We call these the reciprocal. Right, I have a 9 compared to then I have on the other side a 1/9, and that happens all the way throughout. So we end up with the reciprocal in the two columns there as well. Okay, let's look at activity number 2. Just wants to know what the value is. We're going to evaluate an expression for a given value of x. The thing here that we want to look at is that now we have a number in front of the variable. So when I have a number, 2, for example, times x squared, the number in the front of the variable we refer to as the coefficient. Now that number there is something that is being multiplied to this portion when I'm done with it. So if x had a value, if x equaled, let's say 3, then I would do 2 times, and I'm going to do the 3 squared first. This is the part that has to get done first. The coefficient is a number I'm going to multiply this quantity by once I'm done with it. So in this case, 3 squared would become 9, and then I'd multiply that by 2 to end up with then 18. So keep that order in mind here. So in this first one, when I have 3x squared, that means I'm going to do 3, and I'm going to multiply 3 by whatever x squared ends up being. Now x, they tell us, has a value of 10, so I'm going to do 10, and I'm going to do 10 squared. 10 squared is 100, so this becomes 3 times 100, and 3 times 100 is simply 300. Okay, let's do the next one. Here we have 3 times x squared, but the x is going to be what? 1/9 squared. So that's going to be 3 times, well, 1/9 squared is going to be 1/9 times 1/9. And 1/9 times 1/9 is 1/81. So I get 3 times 1/81, which becomes 3 over 81, which reduces down to 1 over 27. All right, so this one right here becomes, we know this one is going to be 300. Got that there. B is 1 over 27. Let's see what happens this one. Here x is going to be 4, so we're going to put 4 in the place of that. So we have 4 to the third over 4. Now again, you can multiply this out. You could think of it as 4, or expand it I should say, 4 times 4 times 4 all over 4. And when you look at it this way, we can reduce, so we're left with simply 4 times 4, which is 16. For number 4, we're going to replace the x to the third with a half. So this becomes 1/2 cubed over 4. So again, to rewrite this, we have a half times a half times a half over 4. To rewrite that, 2 times 2 is 4, times 2 is 8. I have 1/8 over 4. Now this one I have to think about, well, what does that actually mean? This is actually 1/8 divided by 4, right? That's what that bar means. So now when I divide this, I don't divide by 4, I talk about multiplying by the reciprocal. So I turn 4 into the reciprocal and multiply. So we have 1 times 1 is 1, 8 times 4 is 32, and that becomes my solution for that one. There's 1 over 32. For this next one here, we have 9 plus x to the 7th when x is 1. So we'll do 9 times 1 to the 7th power. Well, 1 to the 7th power is simply 1. 1 times 1 times 1 times 1 is just 1. So we get 9 plus 1, which equals 10 for there. And the last one, 9 plus x to the 7th when x is a half. Okay, it's a little more complicated here. We're going to do 9 plus, and we're going to do 1/2, and we're going to do that 7 times. 2, 3, 4, 5, 6, and 7. Did I get them all? Yep. So 2 times 2 is 4, 8, 16, 32, 64, and 128. So you have 9 plus 1 over 128, or 9 and 1 and 1/28, like so. So that becomes our last solution right here, like that. The key with the whole thing is remembering that this is a coefficient, and it's in front of the variable, and so as a result, we just don't want to just do that first. We've got to make sure we do the exponent value first, find out what the expression is going to be equal to the exponent, and then multiply back in that coefficient. That's the key thing there from looking at that one. Let's look at one more activity for today. Now this activity is a little bit more challenging sometimes if you're not familiar with math facts, and if you aren't, that's okay. Just kind of work at doing some guess and check, so to speak. So we'll start off with this. Let's say I had x squared equals 100. Okay, x squared equals 100. So what would the solution to this equation be, and what would that actually mean? Well, to find a solution, we wanted to find out what is the value of x that makes this true. The value of x is going to be one where I multiply x times the same value in order to get 100. Okay, that's what I'm looking for because it's squared. So in this case here, here's a couple options. I have 10 and I have 50. Now, which one would be the best option and why? Would 10 be a good option? Well, let's think about 10. 10, if I squared it, becomes 10 times 10, which equals 100. That makes sense. Why would 50 not quite work? Well, 50 squared becomes 50 times 50, and that's just not what we're looking for, is it? That's going to be a very large number compared to 100. So if we did 50 times 50, we end up with 2,500. Not going to work there. Why do you think they would suggest 50 as a possible answer? Any idea? Well, they would do that for people that said, well, let's do 50 squared, and someone thought that was 50 times 2, which would equal 100. But this is squaring, not multiplying by 2, so this is not correct. Okay, so I'm crossing out, so it's not your notes to look at later and go, oh, it works. So what we're going to do today in the next activity is we're going to try to figure out what value of x makes an equation true. So let's look at the first one. Here we have something squared equals 64. So again, it helps if you know your math facts there. In this case here, if I think about 6 squared, 6 times 6 is 36, so we're a little too short there. 7 times 7 is 49, and 8 times 8 is 64. So the value that would make sense here for number 1 is going to be 8. Right? Down to the next one. We want to get 64, but now we're going to do something squared, or sorry, something cubed. All right, so we already know that 6, doing it 6 twice gets me to 36. If I keep going, it's getting too big. So I'll probably do something less than 6 here. So let's think some options. What if I did 5 times 5 times 5? 5 times 5 is 25, times 5 is 125. That's too large. So let's try 4s. 4 times 4 is 16, times 4 is 64. So we'd say 4 cubed works for that one right there. On the next one, we're going to multiply 2 a certain number of times by itself in order to get to 32. So it's a 2 times 2, which is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32, and we're there. So how many 2's did it take? 1, 2, 3, 4, 5. So we would say 2 to the 5th, oops, and the solution here then is actually the 5. That's the x value. For this one, we can actually solve it to find what x is going to be equal to. So we're going to do 2 to the 5th 3 times, like so. 2 times 2 is 4, times 2 is 8, and 5 times 5 times 5, there it is right there, is 125. So x simply equals 8 over 125. On the next side, we have something that multiplied together to get as a fraction of 16 and 9. 16 over 9. So we're thinking here is what two fractions can, the same exact fraction, can you multiply by itself to get 16 and 9? So when I look at 16, I think, oh, that's not too bad. 16 is made up of 4 times 4. And 9 is made up of 3 times 3. So what is the x that we're squaring? The x we're squaring here would be 4/3. On the next one, we take a look here and we have 2 times 5 2's. 1, 2, 3, 4, 5. In all, we have a total of 1, 2, 3, 4, 5, 6 2's. So the value of x that makes sense would be 6. Right? Or 2 to the 6th power. This next one, 2 times some number gets you 2 to the 4th. Well, think of it this way. We just did one like this, right? How did we get 2 to the 6th? 2 to the 6th was 2 times 1 less than 2 to the 6th. So to get 4, this is going to have to be equaled up to 2 to the 4th. So I already have 1 2. So how many 2's do I need to get to 4 2's total? I'm going to do 2 to the 3rd power, because 2 to the 3rd power is going to get you there. Well, I can also use a regular number. 2 times 2 is 4, times 2 is 8. So I can also think about 2 times 8 equals 2 to the 4th. It all works the same. This is 16, 16. So the x value that would make the most sense, based upon the choices down here, would be 8. In our last one, we have 4 to the 3rd, and 4 times 4 times 4 is 64. And we want to set that equal to 8 to what power? And in our case here, we recognize that 8 squared is actually equal to 64. So we would say 2 for the value of x. Alright, we're not going to do the Are You Ready for More today. Okay, just getting to the end of things here. We're going to look at a summary and then we'll let you work on your homework. So in this lesson, we saw expressions that use the letter x as a variable. We evaluated these expressions for different values of x. To evaluate the expression 2 times x to the 3rd when x is 5, we replace the letter x with 5 to get this type of equation. So 2 times, this is equal to 2 times 125, or just 250. So the value of 2 times x to the 3rd is 250 when x is 5. Meaning we got to make sure that we do this part first. Okay? We do the same thing here when we have a fractional thing. When x is 4, we replace the letter x with 4. And that's the key thing there. So this becomes that. And then we work through it and solve it there. We also did some practice where we had to figure out what could that x be based upon the solution that was given there and kind of work backwards a little bit. You'll have those same kind of questions in your homework tonight, so give it a shot, see what you can do, and we'll come back and check it together in just a few minutes. All right, homework time for lesson 15. It says to evaluate the following expressions if x equals 3. So we're going to substitute the value 3 for x in each of these problems. So a becomes 2 to the third power, which is really 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. The next one, we're going to put 3 in place of x, so we get 3 squared, which is simply 3 times 3, which equals 9. For c, we're going to do 1 to the third, which is just like doing 1 times 1 times 1, which simply equals 1. Here, the 3 goes in place of x, so it's 3 to the first power, which means it's just simply 3. And for e, we're going to do the half to the third power. So this becomes a half times a half times a half, which is 1 over 2 times 2 is 4, times 2 is 8, right? Or like we saw earlier, it's the reciprocal of this one right there. All right, number 2. Evaluate expression for the given value of x. So this first one, it says x is 3. So we're going to do 2 plus 3 to the third power. We're going to do this part first. 3 times 3 is 9, times 3 is 27. So we have 2 plus 27, and 2 plus 27 is simply 29. This next one, x is a half, so we're going to do half squared. So 1 half times 1 half equals 1/4. Our next one, c, we have 3 times, if x is 5, 5 squared. And so 5 squared is 25, so 3 times 25, and 3 times 25 is 75. And the last one, we have 100 minus, and we do 6 squared. So we'll do 6 squared here. 6 squared is what? It's 36, and 100 minus 36 is simply 64. All right, number 3. We're going to decide the expressions have the same value, and if not, determine which expression has the larger value. Okay, using greater than less than, we'll try that. So 2 to the third is 2 times 2 times 2, which is 8. 3 squared is 3 times 3, which is 9. So they're not equal, and this one happens to be bigger. Okay? The next one, 1 to the 31st is simply 1, and 31 to the first power is 31. So this one's larger, so they're not equal. Here we do 4 squared. 4 times 4 is 16. And then we do 2 times 2 times 2 times 2, which is 2, 4, 8, 16. So those are equal there. And our last one, a half to the third power, is a half times a half times a half, which is 2, 4, and then 8. So it's 1/8. Compared to the third, the second power, this looks like the inverse over here, right? Or the reciprocal, which is 1/9. But in this case here, this fraction is actually larger. An eighth is larger than a ninth, so we do this like so. Okay, number 7. Match each equation to its solution. So x is going to have a value of 1, 2, 3, or 4. So the first one, we have 7 plus x squared equals 16. We'll subtract 7, so we have x squared equals 9. So which one of these squared gets you to 9? I would say this one right here. So this is going to be A. X is going to equal 3. For the next one, we have 5 minus x squared equals 1. We'll subtract 4 from both sides, so that negative x squared equals negative, subtract 5 from both sides. So negative x squared equals negative 4. Sorry about that. And then I'm going to multiply everything by a negative 1, both sides, so I end up with x squared equals 4. So what number squared can get you to 4? I like this one right there. So that x equals 2, because 2 times 2 is going to be 4. So we'll put B right there. On C, we have 2 times 2 to the third equals 2 to some power. Well, this is 2 already, and we have 1, 2, 3 2's there. We combine all this together, how many 2's do we actually have? We have 4 2's. So you can see this is 3, and that's a 1, and 1 plus 3 is 4. So C goes there. leaving us with this one right here, which is the same idea. This is 3 to the 4th power, which is 3 times 3 times 3 times 3 over 3 to what other power? Well, we have 1, which is just 1. And if we cross those out, that multiplies together to get you 27, so that makes the most sense right there. Alright, turn the page, so back side. Got a couple review questions for today. Okay, it says an adult pass at the amusement park costs 1.6 times as much as a child's pass. So the adult pass costs us 1.6 times as much as the child's pass. That's what we know. The cost of the adult is whatever the child's pass is times 1.6. So how many dollars does an adult pass cost if a child's pass costs $5? Well, let's multiply 1.5, or 1.6, sorry, times the $5. That's the child's cost. We get 30, 5, and 8, decimal there, so we'd say $8. What about $10? I can multiply it by 10 or recognize that it's going to be double this, isn't it? So this is just going to be $16. It's times 2. And this one here, W, would be, we're replacing the C in our equation with W. So whatever the value W is, multiply by 1.6. Okay, what if the child's pass costs $15? How much is the adult pass? Again, I could do 1.6 and multiply it by 15 to find that out. So we have 30, we have 8, and then we have 1 times 6 is 6, and 1, so we have a total of 24, but we have a decimal here, so we would call that $24. And our last one, number 6, Jada reads 5 pages every 20 minutes. At this rate, how many pages can she read in 1 hour? We have a double number line and a table. So with a double number line, we can see that from 20 to 40, we are multiplying by 2. So 5 times 2, it'd be 10 right there. And to go 20 to 60, I'm multiplying by 3. So 5 times 3 is 15. Can I do that with a table? Sure. I can do the same numbers. I could say, all right, I have 20, 40, and 60, just transferring these numbers to there. And again, this is times 2, which became 10, and times 3, which became 15. Are there other ways of approaching that? Sure there are. Which strategy thinks works better in finding the answer? That's up to you. You can answer that one for your teacher. That's it for today. Have a great day, and we'll see you next time.